Hello students, today in this video we are going to take up a topic from chemistry. So let's see what important topic we are going to start today. Today we will take up atoms, elements and compounds. As you already know that we have atoms all around, right? That means atoms are actually the constitute of matter around us. So we are going to learn more about them in this video. The subtopic which we will be covering in this video is atomic structure and periodic table. So I think this is very interesting topic and this video is going to be very interesting. So let's start the topic. Topics to be covered in this video are introduction of an atom, introduction of subatomic particles, relative masses, charges of electron, proton and neutron, atomic mass, atomic number and mass number, explanation related to structure of atom, and the last topic which we will take up is isotopes, their types and their uses. So let's start. Now, the first thing which we are going to study in this video is that what is matter? What is matter? As you all know that we are surrounded by so many things. Like if I am recording a lecture, I have a board with me, I have a pen with me, I have a chair, I have a table. So these substances are regarded as matter. Likewise, if I talk about you, like suppose you are sitting in your room, so what substances you come across? You come across a bed, a cupboard, or you can say your mobile phone or anything. That all is matter. So in simple words, we can say that anything that surrounds us and has mass and also occupies some space is called as matter. As you all know that we have air surrounding us. So is air a matter or not? Yes, air is also a matter because it also occupies space and it also possesses mass. So chair, table, pen, book, everything that surrounds us which occupies space and has mass is called as matter. So now the question is, what are the constituents of matter? How the matter is formed? So the matter is formed by a small substance that is atoms. Matter is formed of atoms. Or we can say in a simple language, atoms are building blocks of matter. Atoms are building blocks of matter. So let's learn more about an atom. So what is atom? We can define it as it is the smallest particle of an element which may or may not have an independent existence. So atom is regarded as the smallest particle and it may exist independently or it may exist in a combination. It may or may not have an independent existence. So this is what is the structure of atom. So later in this video we are going to study everything, the structure, the electron, proton, neutron, everything related to atom. Now, what is the size of atom? Atoms are very small in size. They are so much small that we need to measure their size in a unit that is nanometer. And nanometer is somehow very small unit. 1 nanometer is equal to 10 raised to power minus 9 meters. So you can see that how small is an atom. Hydrogen atom is smallest of all. And you know what is the size of hydrogen atom? It is just 10 raised to power minus 10 nanometer. So overall the atoms are very small and the smallest one is the hydrogen atom with size 10 raised to power minus 10 nanometer. Now the question is how we represent atoms. So the representation of atoms was given by Berzelius. He introduced the symbols to represent atoms. That is the specific notation which will describe an atom. There is an organization which actually assigns the name to the atoms, or you can say it approves the name of the atoms of an element, or you can say it assigns the name to the compounds. So in this chapter, at this moment, we are studying about the elements, or you can say atoms. So how the naming, or what are the rules to assign the names to the atoms of an element. So according to it, the name of the element, or you can say the symbol to represent an atom, can be first letter of element, or it can be first two letters. For example, if I talk about hydrogen, if I talk about an element, or you can say an atom, hydrogen, so what is the symbol of hydrogen? It is the first letter of the element, that is H. So hydrogen is represented as H. And likewise, there are certain elements which are represented by the first letter present in their name. Or it may be the first two letters in some cases. For example, if I write about helium, the symbol used to represent helium is He. That is the first two letters. So I think the first rule is okay with you. That symbol can be a first letter, or it can be first two letters. We are not authorized to write the symbol by our own. It is provided by IUPAC and we have to follow this. Like if I talk about hydrogen, the symbol is going to be H worldwide. Right? You cannot write HY. It is given or approved by IUPAC as H. That is the first letter. Similarly, in helium, it is He. So you cannot represent it by H. The worldwide acceptance is He. Second, while writing the symbol, the first letter should be capital. For example, as I wrote for helium, the first letter has to be capital, and the second letter is written in a smaller case. So this is the rule, or you can say this is the method of writing the symbol, and you need to follow it. For example, if I talk about another element, let's say argon. If I talk about argon, the symbol for argon is the first two letters. So I need to write capital A and then R in a small case. Right. Now, there is a question, one question I want to discuss with you. For example, if I talk about sodium, right. So the symbol for sodium should be, like as per the rules which we have already studied now, it should be S or it should be SO. But the symbol for the sodium is not, so that means it is neither S nor SO. The symbol for the sodium is something else, that is Na. So that means there are certain elements whose symbols are not their first letter or the first two letters. There's something else. So let's study about the third rule. So there are few elements whose symbols are actually derived from their Latin names. The symbols are derived from their Latin names. So they are the first letter or the first two letters, but not of their English name, but of their Latin names. For example, if I talk about sodium, right, the Latin name for the sodium is natrium. The Latin name is natrium. So the symbol for the sodium is derived from its Latin name, that is natrium. That is the first two letters, that is Na, is used as a symbol. Likewise, if I talk about another element, let's say potassium, the Latin name for the potassium is kalium. The Latin name is kalium, and its symbol is derived from this Latin name, that is the first letter, which is K. So symbol for potassium is K. So likewise, we have few elements whose symbols are derived from their Latin names, but it is either the first letter or the first two letters. So let's see the Latin name for few elements. Like if I talk about antimony, its Latin name is terbium and its symbol is Sb. Second, we have copper. Copper's Latin name is cuprum and the symbol is derived from first two letters, that is Cu. Third, we have gold. The Latin name for the gold is aurum, and the symbol is again first two letters, that is Au. Iron, Latin name is ferrum, and its symbol is Fe. For lead, it is plumbum, and the symbol is Pb. Next, we have mercury. Its Latin name is hydrigium, and its symbol is Hg. Now, few other elements like potassium, we have already discussed kalium, symbol is K. For silver, it is argentum, the symbol used is Ag. For sodium, the Latin name is natrium, the symbol used is Na. For tin, it is tannum, and the symbol used is Sn. See, in this case, you saw that it is not St, it is Sn. So it can be like this for few elements also. So these are few exceptions, that they are not first two letters but something other than first two letters, that is the first letter is taken and some other letter from the word is taken. So it can be like that also. We have tungsten, its Latin name is wolfram, and the symbol used is W. So I think you understood that the symbol can be a first letter or can be a first two letters of their English or Latin names. So this is how the symbols were approved by IUPAC. Now let's do few question and answers. So the first question is, give the symbol of zinc and cobalt. We know that the symbols can be a first letter, can be first two letters of Latin name or an English name. So the symbol for zinc is Zn, and for cobalt is Co. So these are the symbols of zinc and cobalt. The second question is, write the Latin name of following. First we have sodium, second is lead, and third is gold. So the Latin name for sodium is natrium. The Latin name for the sodium is natrium. For lead, it is plumbum. So you are going to write like this, that it is plumbum. And for gold, obviously it is aurum. For gold, it is aurum. So these are the Latin names for the following. The third question is, why symbol of potassium is K, not P or PO? The answer is, as I have already told you, that the symbols can be derived from Latin name or English names. So here the symbol for the potassium is derived from its Latin name, that is kalium. So the symbol is K, that is first letter of Latin name. Next question is, we need to pick matter out of it. We know that matter is a substance that occupies space and has mass. So the first option is air. So air is matter because it has mass also and it occupies space also. Similarly, water is also a matter because it also occupies space and has mass. Similarly, zinc is also a matter, and even for sugar, it also occupies space. You need a container to keep it, right? Because this is also a matter because it occupies space and possesses mass. So answer is that all of them are matter. Next question we have is, expand IUPAC. What do you mean by IUPAC? That is IUPAC. What do you mean by it? So this is International Union of Pure and Applied Chemistry. And we have already studied that it is an organization which actually approves the name of the elements and also the compounds. This is all about the part 1. Rest we'll take up in part 2. So thank you for watching this video, and for more learning experience you can visit to www.versarex.com.